All right. So we're going to talk about reflections. It was in that vocabulary chart from yesterday or Friday, but we didn't really talk much about them. I know you guys have done reflections if you've taken geometry. Which everybody's taking geometry, right? You don't have anybody doubling up right now. Nobody's doubling up right now. So everybody's done reflections, right? Or vertical reflection and horizontal reflection. So, if you have a vertical reflection, it means you're going from up here to down here, or down here to up here. We're going up and down. So everybody right now, give me an x-axis. Give me an x-axis. Put something up here. Now reflect it over the x-axis. Okay, so you see how we're vertically reflecting. You see that? Okay, so we're going to vertically reflect. It is called reflection in the x-axis. That's how we phrase that. That's the vocabulary you are learning, is reflection in the x-axis. And it's confusing because it is a vertical reflection, so that's why we get out our x-axis and pretend and we say, oh yeah, that's reflecting vertically, but in the x-axis. So I'm going to write that down. Ready? Reflection in the x-axis. That is the vertical one. Okay, horizontal reflection. Horizontal reflection means like this. Let's do it. Horizontal, I'm going like left to right, horizontal. So what axis would I be reflecting over if I go left to right? I'm reflecting over the y-axis. Okay? So horizontal reflection is actually a reflection in the y-axis. That's the vocabulary you have to start learning and using on your assignments. You will see in the equation, the vertical reflection, the reflection of the x-axis has a negative sign out front of the function. Over here, the horizontal has the negative sign inside of the parentheses. So what we did yesterday is we did horizontal and vertical things. We did translations yesterday. And the horizontal one always is inside the parentheses. So that's how you know it's a horizontal. So if it's not a negative sign inside the parentheses, then you know it's vertical. So it's inside parentheses, horizontal. If it's not inside the parentheses, vertical. Every single time we do anything horizontal or vertical, the same rules apply. So on Friday when we were doing translations, it was inside, it was horizontal. Same rules apply. Okay, so this next page, we're going to graph and describe reflection. I'm going to start teaching you how we graph using transformations. Okay? So try to follow my steps. First thing we're going to do is we're going to look at the equation, and we're going to say, what is the parent function for p of x equals negative x squared? What's the parent function? Or what family does it belong to? Quadratic. So the parent function, which I've already put on your paper, the parent function is y equals x squared. So in my chart, I'm going to graph the x's and the y's that we wrote on the very first page of our notes for the parent function of x squared. So that was negative 2, negative 1, 0, 1, 2 for the x's. And then the y's, we plugged in negative 2 and we got out 4. Plugged in negative 1, got out 1, 0, 1, 4. That was our parent function. We also have to graph it, so we'll come over here and sketch our parent function. and I'm going to do dashed lines because it's our parent function. If you're using more than one color, then you could use two different colors, one for your parent and one for your regular function. Otherwise, I would just dash the parent function if you're just using pencil. It's really one. Yeah. All right, now, we have a negative sign. And so we go through the notes that we just looked at. If there's a negative sign, it's going to tell us there's a reflection. So we have to figure out which one it is. So you ask yourself, are there parentheses? This is a negative sign inside a parentheses. So it is not horizontal. It must be vertical. So now I get out my hand and my axis, and I'm going to go vertical. What axis am I going over if I'm vertically reflecting? Which axis am I going over right now? So that's the most challenging part. Which axis am I going over? The x-axis. So we say reflect in the x-axis. Because it's going to go up and down, which is vertical. But it's going to go over that x-axis. So now what we do in our chart is we have the parent function. What do we do to the parent function to make it look like the new function? What's the difference here? What's the change? From here to here, how did it change? Yeah, so how do I make something negative? Do I add to make it negative? What do I do? To go from here to here, what operation am I using from here to have a negative in front? Operation sign. Is it addition? All right, let me ask a different question then. What number is here besides negative? It is negative 1. So this is the same thing as y equals negative 1. What with the x squared? What? Operation. Add, subtract, multiply, divide. Which one? Charlie, you know the answer? When there's a number next to a letter, what operation that is? I feel like you should. David, all of you, I'm sorry, not just Charlie, all of you. Nobody's answering me. This is like, add, subtract, multiply, or divide. What is it, David?
Multiplication.
This is multiply. When you got a number next to a letter, it's multiplication, right, guys? Right, guys? I hope you were all like thinking that, because I'm getting kind of bored. Okay. I'm still getting back into school here. That's multiply, right? Okay, so my question is, how did I get from x squared to negative x squared? What did I do? I multiplied by negative 1. So what you're going to do is you're going to go from the purple ones to this one. We're going to take each number and multiply it by negative 1. You're going to keep the same x's. You're going to keep the same x's. You're just going to change your y's by multiplying by negative 1. Then we go and we graph. We graph our same x's, but our new y's. Same x's, new y's. When you graph it, it should look like it was reflected. Okay. Move on. Ready to go. Did I answer everything? Yeah. Okay, the next is state the parent function and the transformations. Draw a quick sketch of each of the following. So we're going to do a quick sketch. It's not going to be super accurate. It's going to be fast. So let's start. The parent function for A. It says f of x equals negative absolute value of x. What's the parent function? What family does it belong to? Absolute value. So we write down the parent function for absolute value, which is on the first page, f of x equals absolute value of x. That's the parent function. Then we have to say the transformation. So we look at the parent function, then we look back at question A. What changed? Aiden, do you know what changed? What operation? Multiplied by a -1. Now, this negative means there's some sort of reflection. Is it going to be horizontal or vertical? So you ask, is it in parentheses, like is it in the absolute value bar, or is it outside? If it's outside, it means vertical. If it were inside, it would be horizontal. This is outside, it means vertical. So then we got to think, all right, it's going to be a vertical reflection. That's up and down. Which axis am I going over? X. Yes, so we're going to write reflect in the x-axis. See all those steps I have to think in my head to get the right answer. Now we're going to do a quick sketch. So the first thing you're going to do is sketch your parent function. And if you don't know the parent function, it's on the first page, but it's a V and it goes straight through the 2 quadrants. And then we're going to do a quick sketch of the reflected in the x-axis function. So if I'm going to reflect this over the x-axis, it would be the same thing, just facing down. And if you're not doing a difference between your parent function and your new function, it's hard to tell. It looks like an X and you can't tell what's what. So that's why I'm making sure that they look different. Or you can use 2 different colors if you want. So in your homework, you're going to be doing some quick sketches like this. B is f of x equals x squared plus 5. We need to know the parent function. F of x equals x squared. Then from there, we need to know the transformation. So this one has plus 5. You always ask yourself, are there parentheses? No, so it's not horizontal. It's got to be vertical something. So what is it when we add 5? What does that do vertically? What's the correction? Translates up 5, right. Translate up 5 units. And then we will sketch our parent function, which is a U shape. That's a down shape. A U shape. And then we will translate that up 5 units. There you go. So there's no parentheses. It is vertical. If there is parentheses, it's going to be horizontal. Question C. F of x equals x minus 2 in parentheses squared. So first of all, we need parent function. F of x equals, which parent function would this one be? Any guesses? Emma, do you have any idea? No, not linear. I would see why you'd think that, because it says x minus 2. Outside of the parenthesis, though, is something that makes it not linear. What's outside the parenthesis? Read.
Is it quadratic?
It is quadratic because of that squared. That means the x will get squared if I were going to multiply it all out. So this one is quadratic, so our parent function is f of x equals x squared. So now the transformation. Is there parentheses? Yes. What's happening inside of the parentheses? A subtracting 2. So since it's adding or subtracting inside, it's going to be horizontal. And it's going to be opposite of what we think. So it's going to be translate which direction? Correct. Right 2 units. So we have our U-shaped parent function. And then we're going to translate that right 2 units. And there is our wave function. And this is a quick sketch, so you don't have to have super accurate graphs, just correct shape and approximate location. And then you'll see at the very bottom of the paper where it says, now let's use the tracking calculator, which some of you need to get ASAP. Okay, we're not going to do that part right now. Go to the next page. Just have a few more minutes. So next is vertical stretches and shrinks. All right. Have you guys stretched your arms today? So we're about to do some strenuous stuff. You ready? You've done it already? Excellent. Okay. I need for you all to, we're going to do what's called kinesthetic learning, which means hands-on, like you're going to actually do it. I need you all to give me an absolute value motion with your arms. Oh, I feel so good to stretch like that. That was a W for a second. All right, now, wait, no, we're not done yet. Hold on to it. I'm going to come over to you, not really, but pretend. I'm coming over to you, and I'm going to take your arms, and I'm going to vertically stretch them. What's going to happen to your arms if I'm vertically stretching them? Stretching them, what's going to happen to them? Like, I'm pulling your arms up. What's going to happen? Yeah, they're going to, okay. You can shake it out. You can shake it out now. Yeah, they're going to totally like narrow when I vertically stretch. When I take your arms and I pull them up, they're going to narrow. That is a vertical stretch. That's what happens to a graph when you vertically stretch it. Okay, so if we had a line, give me a line. Give me a line. Any line. That's not one. All right. And then, this is not one. And then I'm going to take whatever arm is higher and whatever arm is lower, and I'm going to vertically stretch them. Your line's going to come flat. Okay. All right, so those are stretches. Should we do absolute value again? I like the absolute value. Or we do per output trip. Absolute value? It's easier to do absolute value. Give me an absolute value, give me an absolute value. Do it. Now, what I'm going to do is I'm going to take your arms, and it has to be a V shape still, but I'm going to push them vertically down. What's going to happen if I push them? See that? Look at that. It's going. It's going. I'm going to push them down. They're going to vertically shrink. That's a vertical shrink. It's going to be wider. Okay? To tell in the equation if you have a vertical stretch or vertical shrink, to tell in the equation, you're going to look and there's going to be a number that is multiplied in front. This number multiplied in front. If that number, right here, here's the important part. If that number is bigger than 1, it is a stretch. If that number is bigger than 1, it is a stretch. I should not see you on your phone right now. That would be a terrible decision. If the number is between 0 and 1, that means it is a fraction between 0 and 1. If it is between 0 and 1, it is a vertical shrink. So a stretch is bigger than 1. A vertical shrink is between 0 and 1. And there's something I did not include here. So I have bigger than 1. I have between 0 and 1. What happens if it's less than 1? Whatever multiplying by a number that's less than 1. What kind of numbers are less than? Less than 0. I'm not saying the right thing. No, less than 0. What numbers are negative? What numbers are less than 0? Negative. Negative. So what happens if I have a negative number multiplied by? 3.
This is a final call for all students. If they haven't yet taken their picture, please go down and get it done in the auxiliary gym.
Okay. If there's a negative in front, what we just did prior to this. There's a negative in front. What is it? What is it? On the previous page, what did we just reflect? Well, it's a reflection. If there's a negative number, it's a reflection. So this does not include reflections. This is just talking if there's a stretch or a shrink. It's not talking about if it flips over. So if there's a negative number in front, it has two things. It has a stretch and shrink, and it also has a reflection if there's a negative. Okay, let's do an example with this. So here we have f of x equals 2 absolute value of x. First of all, what is our parent function? What is the family? Absolute value. So our parent function, I did not put in here for you. Fill it in. Parent function is f of x equals absolute value of x. Put that in there. And then we're going to go to the front page of our packet, and we're going to fill out the parent function of x's and y's. So that's -2, -1, 0, 1, 2, and then absolute value makes everything positive, 2, 1, 0, 1, 2. And then we'll graph that too. We have our parent function graphed. And we're going to look at the equation, and we're going to see how is this equation different than the parent function? How? How are they different? Emma, how are they different? You don't have to tell me transformations, just tell me how they're different. What's different? There's a 2, right? There's 2. Timothy, what operation is with that 2? It's multiplying. If it's next to it, it's multiplying. So this is either a stretch or a shrink. So then we have to go to that chart and we just see, is this number a stretch or a shrink? So in that chart, it said, if the number is bigger than 1, is 2 bigger than 1? Then it is a stretch. So we write a vertical stretch and then you continue to write by a factor of 2. And you just say what you multiply by. Vertical, by the way, vertical spelling, just vertical, C-A-L, vertical. My handwriting's not very good up here either, or ever. Yeah, it doesn't. So what, Timothy, you just told me, what do I do from this one to this one operation-wise? What do I do from this one to this one? You multiply by 2. So I'm just going to take all of these and multiply them by 2. And put my answer 2. So we're doing the operation that it says to do, multiplying by 2. So I'm going to go ahead and graph. When we graph, we don't graph the ones we've already graphed. We graph the old x's and the new y's. We graph the old x's and the new y's. Your graph should look like I took your arms and pulled them up and it is a stretch. Okay? Now we are not getting through all of these notes today with the shortened period, so we will finish the notes tomorrow. But I'm handing you your assignment today. You should be able to do a bit of it. You should be able, we didn't go through all the notes, you should be able to get through about 1 through 11. And then what you do tomorrow is if there was a question that you had in 1 through 11, you come and you ask tomorrow before we actually grade this on Wednesday. So it will be graded on Wednesday, it will not be graded tomorrow. But you should be able to do 1 through 11. So if there's a question, 1 through 11, you don't know how to do yet, come tomorrow, ready to ask. Got it? 1 through 11, come with questions. Past 11, I haven't showed you how to do it yet. And also, you might just have questions on 9. We only did 1 example. You might just have some questions on any of those. All right, where's my